This tutorial is all about keeping the costs of industrial chemicals low. We'll look first at the Haber process, but then generalise to other industrial processes which also make other industrial chemicals. We'll look at the factors which affect the cost of making a new substance, particularly chemicals, and then look more specifically at how we can reduce those costs. So considering that you are making ammonia, you've got to consider what are your one-off costs and what are your daily costs. Well, your one-off costs are the cost of your factory, which is the site where you're making your ammonia, and any industrial equipment you're going to use for that. And I guess also the catalyst, because in theory at least the catalyst can be used again and again and again and doesn't get used up. Your daily costs are going to be your starting materials, your raw materials of nitrogen and hydrogen, your energy, which is going to be your gas and electricity to get the temperature up to 450 degrees and the pressure up to 200 atmospheres of atmospheric pressure, and also your wages. You've got to pay the workforce. So how are you going to reduce each of these to make it a minimum and make your ammonia as cheaply as possible? Looking at one of your daily costs, your raw materials. Well, you have some raw materials that don't react, and therefore recycling unreacted starting material will save you money. Your wages bill, paying your workers, is going to be one of your largest costs. To keep this down, automation is used as far as possible. The energy bill is also enormous, so controlling the temperature is very important. An optimum temperature of 450 degrees is used. A higher temperature would give a faster rate of reaction, but it wouldn't be financially viable. High pressures will also make the reaction go faster and faster, but there comes a limit where increasing the pressure to a very high level would cost too much money, both in terms of the energy needed and, more importantly, in terms of the strength of the equipment that you would need to hold the gases. So, we can reduce the cost of the plant and equipment costs by keeping the pressure to a reasonable level. In industrial processes, catalysts are great. That's because catalysts will speed up the reaction and yet won't take any part in the reaction, so the catalyst isn't used up and can be used again and again and again. In any manufacturing process, and industrial chemicals are no different, we have to be as competitive as possible and keep our costs down. So we don't use a very, very high temperature for the rate of reaction. We use a compromise, which gives us a fast enough rate but at a reasonable price. We don't use too high a pressure, or we'll need to buy very expensive equipment. We use a catalyst wherever possible because that will speed up the reaction and yet won't get used up in the reaction. We use as much automation as possible to keep down the wages bill, and wherever possible we recycle any unreacted starting materials to save on the cost of our raw materials. Here's an exam question. One of the costs of making ammonia is paying for the gas and electricity. Write down about other costs of making ammonia. Well, for example, one cost is the wages bill. Another is the raw materials. There are other answers, and we'll have a look at the mark scheme now to see what else was accepted. So we could also have had the cost of the equipment, or the plant as it's called, the cost of the catalyst, or any other ongoing costs like rent or rates or water. Ammonia is made by the Haber process. The Haber process runs 24/7 and doesn't stop. What's the name for such a process? This is called a continuous process. One of the costs of making ammonia is the cost of the energy used. Write about other costs of making ammonia. Again, it's a 2-mark question, so suitable answer might be the wages bill. We might have, for example, the cost of raw materials. Again, as we can see in the mark scheme, similar possible answers for that second part of the question.